We have created a machine learning algorithm to detect the messages is spam or not. In this, we have a data of around 5000 SMS with the label of ham and spam. In this, ham means that message is not spam and spam means it is the spam. For that, first we have processed our data like dropping duplicates, converting into lower cases, removing stop words, removing punctuation and lemmatization. Uh, uh, to convert text into lower, for that if we do that because we cannot get duplicate columns for the same words, like if someone send message hi in capital and someone send it in small, it will duplicate in the columns. So we have created it to lowercase. Then after we have removed stop words like common words in English language like I am, you are, like that. Then remove punctuation and lemmatization. Lemmatization works like it will make same words of played, playing. If there is a words like play, playing and played, it will make it same as play. So we have created this data pre-processing. Then we have plotted the word cloud for spam messaging and not spam messages to see the most frequent words in both the SMSs. As per our spam word cloud, we can see that there are um, frequent words like free, call, claim, text, stop, and like that. And for not spam messages, there are words like go, IM, LTGTU, which had no sense. So after that, we converted our text into vectors using term frequency vectorization. In this, the each word is counted, and the each word has given a columns. So if the first sentence have I, then in I column, then it is counted as 1. This is the mostly a sparse matrix because we have around 8970 columns, and in a single sentence there are 8 to 30 words. After that, we have used TF-IDF vectorization. In this, each word is counted for term frequency, and its frequency is getting updated using the frequency of that word into whole purpose. After that, we use the Google's word-to-vec model to convert that whole text into a vector of length of 300. Google's word-to-vec model works like it has a dictionary which has words and their vector value. So in this, we have created vectors for each word in sentence and then sum it up to create a one vector of length of 300. And like that, we have created the vectors for all the messages and give them a labels. Then we have created some heuristic features like phone number and length. In this phone number, if the message contains phone number, then we have give it to a 1, and for length we have calculated the length of message in that particular message. So now after this, my friend Gautam will explain the flowchart.
Coming to dimension detection and visualization, here dimension detection, for this we perform principal component analysis to reduce the dimension of the matrix. This means transforming high dimensional data to the low dimensional data without any change, loss of information. Now we have around 9,000 columns. So we use PCA to reduce the number of columns with the 95% of variance. Coming after, PCA on TF data frame. We applied PCA on TF data frame with 95 percentage. Then we got 2126 components. Before PCA, it is 8970 columns. mm, we'll see that results in the this graph, means the picture. After that, we did TF-IDF that PC on TF-IDF data frame with 95% of variance, and we got that 2877 components. Mm, After doing PCA, we reduced to before only 8970 columns. We reduced to 2877 columns after doing PCA. Coming to PC on what to wake, with 95% of variance, before PCA to what to wake, we have 3000 columns. After it reduced it to 189 columns. Coming to this heuristic approach for dimension reduction, heuristic approach means we will um, get simpler results. That's why we did heuristic approach. For TF-IDF data frame, we got 1,332 columns out of 8,970 columns. And another approach for TF-IDF, we got 514 columns out of 8,970 columns. The, this Python code results to be seen. After that, Himanshu will explain um, on competing models.
So now talking about the models, we have fitted logistic regression, decision tree, support vector classifier, ADA boost, and bagging classifier on all the three data frames that we have received, which was the TF, TF-IDF, and word-to-vec models. So when we were fitting the model, we saw that there was class imbalancing. So we applied smooth on every data frame. Then we started fitting our models. So we first fitted models on TF data frame. It was first logistic regression wherein we got FN score of 94 and 95. For decision tree classifier, we got FN score of 76 and 83. For random forest, we got 86 and 81. For ADA boost, we got 92 and 93. For bagging classifier, we got 92 and 93. For support vector, we got 95. Then we started fitting models on TF-IDF frame. In logistic regression, we got FN score of 96. Decision tree classifier, we got FN score of 95. Random forest, we got 93. ADA boost, we got 98. Then we started fitting models on word2vec. So decision tree classifier gave us 93, which was the simplest model. Support vector classifier also gave us 98, which was the best one for word2vec. So now finally concluding the models. For TA vectorized data, we were getting highest FN score for both the classes with SVC and logistic regression. For TF-IDF, we got highest FN score of 98 with SVC. For word2vec models, we were getting FN score more than 93 for everything, but SVC and AdaBoost gave us the best FN score of 98. And thank you.